I think everything's working. I just want to double check. Let me just make sure. I've been having some. I've been having some technical difficulties, so please bear with me. I'm just gonna confirm that everything is working properly. Mic test, mic test. Okay, everything is a go. Hey guys, sorry, it's been a little bit since I last streamed. Pretty hectic week for me last week. A lot of things happened and a lot of unexpected things happened. Nothing bad, but pretty good stuff happened for me over the weekend. So I've been doing a lot to prepare myself, just continue to study. Hope everyone had a great week, had a great weekend. If you watched the Super Bowl, I hope you enjoyed that as well. It was a pretty good game. Um, so it's been a while since we streamed. But we're picking right back up, right back into networking essentials. I know that we were going to talk about IPv4 and IPv, like logical ANDing and subnet masking, but I want to hold that off a little bit. One, it's a pretty like lecture heavy kind of chapter, and honestly, I didn't want to bore anybody um, bore anybody with that. Um, and plus, DHCP is a little bit more. I think DHCP at least is a little bit more relevant in terms of like people use. I mean, not to say that you don't use IP addressing, but I just feel like this would be a better chapter. You know, especially to come back after a little bit of a break. This would be a pretty good chapter to just get us back on track. So without further ado, let's get right into it. So, DHCP, we talked about it briefly in earlier streams and lessons, and DHCP stands for Dynamic Host Configuration Protocol. And we talked about how DHCP can, um, well, number one, DHCP is responsible for assigning you and I uh, our IP addresses, right? And most of the times, your DHCP server is going to be set up so that it can automatically assign IP addresses. Unless you're like a sysadmin, you really shouldn't, or you can uh, manually assign IP addresses. You can do that as well, but um, from my experience, I don't know anybody that manually assigns DHCP um, IP addresses unless you're, like I said, a sysadmin or um, or some sorts. Um, so yes, so we set it already. You can either be set up statically or dynamically. Statically meaning manual, and dynamically meaning automatic. And your DHCP server is responsible for giving you your IP address, your subnet mask, and the IP address of your default gateway. Um, Now, there are some reasons why you would probably want to statically assign IP addresses, meaning there would be reasons why you would want to manually assign IP addresses. Um, Number one, you may have some devices that you want to have a fixed address. Um, we talked about um, like every time we talked about how logical addresses change, right? When you go to a different location, like if I go to a library and then I go to a coffee shop and then I go back home, most likely I'm not going to have the same IP addresses in those three locations, right? But we also talked about how our MAC address, our physical address, always stays the same, right? Because it's physically embedded in the NIC. Why would you want to assign why would you want to manually assign IP addresses? Yeah. Um, like I said, if you have certain devices, like you got a printers, maybe some companies still have, I don't know, those fax machines, um, maybe the gateway, the default gateway, you want to manually assign that. Maybe as a sysadmin, you yourself want to assign yourself your own address, right? So there are some reasons why you would want to statically assign yourself um, IP addresses, but there are some cons to that, right? Um, Number one, let's say you work in a large corporate setting with thousands of employees, right? Well, imagine trying to assign 1,000 IP addresses. That's definitely not going to be fun, right? So manually assigning 1,000 people is very, very difficult, and you're probably going to make a mistake, right? You probably will make a mistake, and you accidentally might assign two people the same IP addresses, and those two people are gonna have a field day, right? And you're gonna be like going crazy trying to figure out what's going on, and then you realize, oh man, I just assigned these people IP address, the same IP address. So there are pros and cons um, to it, but you generally probably want to do dynamic IP addressing, right? Um, so every time you connect to a new network, every time you connect to a coffee shop, library, any Wi-Fi, right? Even your friend's Wi-Fi or anything, when you get when you when you join that network, the DHCP server is automatically going to assign you a IP address, and there is a four-step process to it, which we will get into. There's a four-step process in receiving a IP address, and we will get right into that. And again, DHCP automatically assigns your IP address, your subnet mask, and again, your default gateway. So very, very important to know that. And again, oh, if you statically assign, you also got to, give a subnet mask, and you got to also designate the default gateway. Again, we didn't really get to talk about subnet masks too much, but remember in the Try Hack Me lab where we talked about subnet masking, it's pretty much the subnet mask is pretty much going to identify what network you're on. And this part right here is pretty much going over what we just talked about. Every time you go into airport, coffee shop, wireless hotspot, wherever, as soon as you enter that new network, the DHCP server is going to assign you an IP address. That way you can start communicating with people in your in the network, and hopefully it'll like we said, it gives you your router, so you'll also be able to hopefully reach the internet if everything's working properly. Um, so let's see, who is responsible for statically assigning IP addressing information? The network administrator, probably. The operating system installed on the device, nope. The manufacturer of the device, nope. The user of the device. Now, technically speaking, technically speaking, this could be a right answer, but we want to pick the best answer. So that's probably going to be your network administrator, right? System administrator, network administrator. What protocol is responsible for automatically assigning IP addressing information? And it's the protocol of the hour, DHCP. Let's check. Yes, and we got that. All right. So we mentioned briefly before, um, there's a four-step process in the DHCP. In For you to get for you to get an IP address, there's a four-step process, right? And this four-step process begins with you as a client. You're gonna send out a DHCP discover message, which is a broadcast within the it's a broadcast with a destination IPv4 address of 255.255.255.255 and a destination MAC address of FFFFFFFFFFF. All hosts on the network will receive this broadcast DHCP frame, but only a DHCP server will reply. So this is almost like ARP, right? Remember ARP, Address Resolution Protocol? It works pretty much the same way, right? ARP is a broadcast message, and what's the point of ARP? Remember, ARP is you have the IP address, but you don't have the MAC address, so your computer is gonna broadcast the entire network, and it's asking who has the IP address of this 192.168.1.1, right? And whichever device has that IP address will reply, I have that IP address with an ARP reply, and within the ARP reply, it's going to contain its MAC address. Pretty similar to ARPing, the DHCP discover message, right? This DHCP discover message is a broadcast message that's going to be flooded out to the network, and the DHCP server is going to the DHCP server is going to receive this DHCP discover message, and it's just basically the client asking, I'm new to the network. Who's the DHCP server? I need an IP address. And so the DHCP server, once it receives the discover message, is going to reply with a DHCP offer message. And then within that offer is the DHCP is going to offer us an IP address to lease, right? It's going to be like, hey, here, this is an IP address. And we as a client, when we receive this offer, we're going to accept it and reply with a DHCP request, meaning, yes, I will take that IP address. That's cool with me. And then you send that request, and the DHCP server will say, okay, cool, we lock it in, and it's a deal. And that's the four-step process. It's pretty easy. DHCP discover again, broadcast, flood. Think of it, it's almost like an ARP. You broadcast out the network and you're asking who here is the DHCP server. I'm new. I need an IP address. DHCP server gets that message and it's going to reply with an offer. And again, in the offer contains the the IPv4 address, and we as a client, we want to accept that, right? And so when we accept, we send the DHCP request, and then the DHCP server will acknowledge that. And here you can see on this, I guess this image right here, you can, if you go on your router and if you ever want to like access your router, type in the router IP address, right? So if you're on a Windows machine, you just type in netstat or ifconfig, and it will let you know your default gateway. And usually your default gateway is going to be the first IP address in the network. And then, you can access it. You can access your router, and then all routers are not going to look the same. I'm Verizon, so Verizon doesn't look like this, but it's pretty much similar. There are similarities in here. And then you can go into your setup, and then here you can change the type of way that the DHCP assigns, right? You can have it automatically assigned, or you can have it manually assigned, meaning you can assign it yourself. Um, you can um, you can also configure it and let it know, hey, I want you to start handing out IP addresses at 100. I don't want anything below 100. I want all IP addresses to start from 100 up to 254, right? 192.168 network. It's a Class C network, meaning up to 254 hosts. And then you can also max out the hosts, right? You can max out how many people can be on your network. Maximum number of users 50. So you can see here the address range is from 100 to 149. Only 50 people can be on the network. And if there are more than 50 people, you're not going to be able to join that network because you're not going to have an IP address. And that is it for this chapter. I know this was a pretty short one, um, but DHCP pretty straightforward. Oh, also, I guess there is one thing I did forget to mention, right? So when you get these addresses, they're not permanent. What do I mean by that? Um, they're leased, meaning Um, depending on the way the DHCP server is set up, uh, let's say you're on that network, like your home, like let's say you're on a coffee shop, right? And that coffee shop has a limit of 100 people, and they only want to sign from 192.168.0.2 all the way up to um, 102, right? They only want to sign 100 people. Those addresses are all leased, right? Remember, these aren't permanent, right? Every time you go to a different network, your IP address is probably not going to be the same. And so there is a DHCP pool, and in this pool are the list of IP addresses that it can assign. And that's what we call the DHCP pool. And those IP addresses in the pool are like leased, right? You get to temporarily use that IP address, and once you're finished, and you start logging out and things like that, your computer is probably going to send a DHCP release message, meaning that it's just gonna give up the IP address, and it's gonna let the DHCP server know that, and the DHCP server will acknowledge that and say okay, and then it will know I have this IP address again to assign to a new user. So that is one. I guess that is one important thing to know um, with DHCP and um, when you're getting assigned an IP address and when you give up an IP address. And again, these IP addresses are leased; they're not permanent. Um, so I guess let's just test our knowledge. Which destination IPv4 address does a DHCP v4 client use to send the initial DHCP discover packet when the client is looking for a DHCP server? This was a broadcast, so 255, 255, 255, 255. Which is a DHCP which is a DHCP v4 address allocation method that assigns IP addresses for a limited lease period. So We talked about addresses being leased. Um, I think it was here, the lease. So a dynamic addressing is done, provides automatic assignments such as IP address, subnet mask, and default gateway. It can allocate IP addresses for a configurable period of time called a lease period, right? When the lease period expires, the DHCP server gets a DHCP release message. The address is returned to the DHCP pool for reuse. So that is going to be dynamic allocation. Which DHCP v4 message will a client send to accept an IPv4 address? Accept, right? We didn't talk about unicasts, so it's probably not unicasts. Remember, DHCP acknowledge is the server acknowledging to the client that okay, you got this IP address that I assigned you. So with the process of elimination, DHCP request is probably going to be the correct answer. I just want to double check something though. Sorry guys, because um, I know that we didn't get to talk about unicasts because unicast was in the IP address chapter. Our host on the network will receive the DHCP will serve, the server will send, then the host sends a DHCP request. Mm, bu- 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 bum. Da, 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 da. Client send DHCP discover message with a broadcast. All hosts will receive this broadcast. The server will respond, suggesting this host. Yeah. Hmm. I want to say, hmm, because the initial discover message is a broadcast. Now, once it establishes communication with the DHCP server, I don't see why it will continue to broadcast. So I want unicast, DHCP request, unicast. Let's go with unicast. So just to elaborate, unicast, as the name suggests, uni meaning one, so just one-on-one conversation, right? Broadcast meaning everybody, unicast meaning like a one-on-one conversation. Uh, Refer to the exhibit. A user is configuring a PC with the IP settings as displayed, but the operating system will not accept them. What is the problem? The IP address is not a usable host address. The DNS settings are not configured. The gateway address is not configured. And the subnet mask is wrong. So the answer is IP address is not usable. Um, the DNS server, the DNS settings are not configured. That that has nothing to do with having a IP address, right? Again, the DHCP server mainly is to assign you an IP address. It doesn't matter about the DNS. So the DNS server and settings has nothing to do with you getting an IP address and that IP address working. Subnet mask, I mean, this subnet mask looks okay to me. Again, subnet masks are just used to identify the network that you're on. And technically speaking, you don't need a gateway address to communicate with others on the network. So we're going to go with IP address is not usable. Which two types of device are typically assigned static IP addresses? Okay, so probably our printers, and it's going to come down to workstation and laptops. Those aren't, are always going to get something else. It's going to come down to hubs and web servers. But I don't know if hubs require an IP address. Let's go with web servers. I mean, if we get it wrong, we get it wrong, right? And we learn from our mistakes, right? A DHCP enabled client PC has just booted. During which two steps will the client PC use broadcast messages when communicating with the DHCP server? Okay, so uh, this question right here is going to correct us because um, broadcast DHCP request. Okay, because this question just says that what are the two steps that the client PC will use to broadcast. So sorry guys, I led us astray on this one. It seems like all the messages between the client and the server will always be broadcasted. So broadcast DHCP request to accept the offer by the DHCP. So the two are DHCP discover. Remember, client sends a discover message. It's asking who's the DHCP server. And then the DHCP server will respond with a DHCP offer. And that offer is the IP address that it's offering us. And we as a client will send a DHCP request, meaning we accept that. And then it finishes off with a DHCP acknowledgement. Which two reasons generally make DHCP the preferred method of assigning IP addresses to hosts on a large network? It ensures that addresses are only applied to devices that require permanent address. I don't know. It eliminates most address configuration errors. Probably. Let's go with that one. It provides an address only to devices that are authorized to be connected to the network. I don't think it does that. It reduces the burden on network support staff. In a large network, you best believe it. It guarantees that every device that needs an address will get one. Um, Not necessarily. Remember, what if you limit how many devices are allowed to be on the network, right? So if you limit the amount of IP addresses that you can lease out, it doesn't matter how many devices are on the network. You can have, you know, let's say you configure the DHCP server to only have 100 100 addresses to lease, and there's 101 users. Well, that one user is not going to have an address, so you're not guaranteed to get one. If more than one DHCP server is available on a local network, in which order will DHCP messages be sent between a host and a DHCP server? If more than one DHCP server is available on the local network, in which order will DHCP messages be sent between a host and a DHCP server? So we always know it starts with discover, and then an offer, and then a request, and an acknowledgement. Remember, discover is always going to be the first step, no matter what. And then, these other ones didn't even start with discover, so we can rest assured. So a DHCP server is used to assign IP addresses dynamically to the host on the network. The address pool is configured with 192.168.10.024, meaning this is 24 bits. Remember, 24 bits dedicated to the network portion. And then 8 bits dedicated to the hosts. There are 3 printers on this network that needs to use reserved static IP addresses from the pool. How many addresses in the pool are left to be assigned to other hosts? This is a trick question. This is a pretty trick question because we have our router that's always going to have its IP address. And a subnet mask prefix value of 24, there's always going to be 254 hosts, right? One for the default gateway. So, I think the answer is going to be 251. You know, with one always going, you're going to take one away for the default gateway, and then you take 3 more out. I think the answer is 251. Which statement is true about DHCP operation? A client must wait for a lease expiration before it sends another. Nope. If the client receives several DHCP offer messages from different server, it sends a unicast message to the server from which is. No, I don't think so. When a device that is configured to use DHCP boots, the client broadcasts a DHCP discover message to identify any available DHCP servers on the network. That sounds right. The DHCP discover message contains the IP address. Nope, that is not right. So let's check and see. If we don't get them all wrong, or if we don't get them all wrong, if we don't get them all right, I apologize. Hey, and we're 10 out of 10. What do you know? We got it perfect. So, yeah, interesting. Hubs was not the answer for that one. And 251. So, I was not. Yeah, we did it, guys. So that's all I have for today. I know that it was a pretty short stream, but um, it was a good one though. We learned a lot on DHCP, and this one next chapter we're going to learn. Let's see, the next chapter we're going to learn routers and gateways, routing between networks, and yeah, NAT. This is gonna be good. Um, yeah. So next chapter we'll talk about network boundaries and IPv4 and IPv6 address management, why we use IPv6. Um, you'll find out. Simply, we just ran out of IPv4 addresses because IPv4 was made way back then in the days where we didn't know smartphones and laptops and all this would exist. Internet IoT devices would exist. So, anyways, I hope you guys learned a lot. I really enjoyed tonight. I hope you did as well. And hopefully, I will see you guys tomorrow. If not tomorrow, pretty soon. All right. Take care. Bye.